Hello everyone, so I'm Ashwin. I'm just talking about software today, so about FAIR principles, but in the software and workflow space, and platforms like it. So I'm mostly be covering these 5 topics today. So we'll start at the beginning, which is what the problem we're trying to solve is. So the first point is we want to approach software and workflows and pipelines with a fair mindset. And in this case, I think from even a reusability point of view, we also want to talk about reproducibility, which is pretty applicable to software and pipelines. So typical challenge for a researcher is most workflows are built upon pre-existing workflows. We take something that's there and then modify it to fit your use case or your data. But where do we even find these workflows and start? And then when you get into it, how do you modify it and make it work for your use case and then troubleshoot all those issues and resolve them? Then at the end, you still have to find an effective way of sharing the workflows. And workflows are all dependent on a lot of things like code, data structure, and organization, and also results and visualization and things as well. So this is caused by a couple of, I think, major issues and challenges in general scientific data analysis. Starting with reproducibility. So when we have workflows in 2 different software computing environments, different dependencies and different operating systems, they have a tendency to work differently. And sometimes a lot of things like in neuroimaging analysis and biomedical imaging, we have a lot of softwares that have dependencies and libraries, and in a pipeline you have to combine them together in order to get your full end-to-end workflow going. And they might have conflicting dependencies, and it might not even be possible to have multiple versions of things installed on the same system. Following that is also from a typical workflow development perspective, you often prototype it on a laptop or something, and then we move on to a workstation to go large and run more heavy analysis. And then eventually you want to be running on large sets of data on HPC or cloud. But then now you're going to have to move or rebuild your entire workflow and analysis environment on every single computing infrastructure you want to run on. Then there's data management. There's data management in terms of data types, data structures, and in the biomedical imaging space where we're from, there's a lot of data types and data structures and formats and things like that. We need a lot of tools to structure that data, and these are all software tools. We need to be able to run them very easily and effectively. And also another thing is data storage and privacy. Healthcare data has a lot of, might have secure and private information, sensitive data and things like that, and metadata as well. Then they might have data storage restrictions. They can only be stored in certain locations. Now we've got a problem where data has a specific location, but then your software and stuff might be somewhere else, or your computer's available somewhere else. So how do you bring these 2 things together? So, and this is all, at the end of the day, one of the big problems is installing and maintaining software is not fun and it's not easy. It's very complex, especially across various different computing platforms and across various different softwares that are often used in a lot of biomedical imaging pipelines. So one of the existing solutions is a project I've been worked on with a great team, and actually we have a lot of contributors all over the world actually, and this is just a short list of them. It's the NeuroDesk project, where we wanted to tackle this challenge in the neuroimaging space. So basically what NeuroDesk is we took a lot of neuroimaging related software and applications and we containerized them and then packaged them into a larger container, which is also a virtual desktop platform. And now this larger container can be moved around and portable and then run in the environments that it needs to. That's the overall architecture of our NeuroDesk platform. So to start off, at the heart of it is the software application containers. So every single research software application we want to run, we containerize it with all its dependencies in our operating system. So now this is a portable and a unit of software that we can then plug and play in order to bring it together to form a pipeline. On top of this, we built an accessibility layer so that when you interface with a software container like this, you don't even have to use the container code or command line. You actually just run it directly because the accessibility layer exposes the container as if it's installed natively. Therefore, you don't have to worry about things like your containerization engine and things like that as well when it comes to writing your code or your workflows. Then we deploy these containers onto various different infrastructure and locations. This includes things like your laptops and your workstations, but also extended to HPC clusters and Jupyter notebooks, and actually even on MRI scanners. That's something we've recently gotten some progress on. And lastly is the community. So the entire platform is designed so that community can contribute the software containers for the applications that they require. And once we have built a platform to automatically build and then deploy these softwares in various interfaces. And at the end of the day, they get to benefit from it because they can use it in their analysis. So what we're trying to do is we want to try to enable an open data lifecycle in the biomedical imaging space, and specifically the neuroimaging space in this case. And it starts with trying to get your data onto a system. We want to process the data with various different tools and then organize it, do data management, and then finally share it with the community. And we've been trying to create a platform that's portable and also flexible enough that it's able to enable every part of this chain. So we've been pretty happy with the uptake in the community, with more than about 1,000 new monthly users and from over like 60 countries. And our core platform container has actually been downloaded 16,000 times. And we've also had this used for different university workshops and learning courses and things like that as well. So today's roadmap is about what is the next stage of this. So this started with something that the National Imaging Facility had started recently, which is a data program. So they wanted to build a consistent data infrastructure across the Australian national imaging space. This is effectively solutions for doing data management and analysis, the core infrastructure, the software infrastructure that underpins all of that, and standardize it across most of its nodes. And there was a business case submitted and we're successful. And this is now a $10 million project consisting of 12 of the National Imaging Facility partners. And what we're trying to do is build together a platform, a distributed platform across all our different nodes that use a common technology stack underneath so that then we can collaborate effectively across the board. The effective platform is the Australian Imaging Service, and the AIS director, Ryan, he'll be presenting this tomorrow, so I won't go too much detail into AIS itself. But as part of this, we needed an interactive analysis and a analysis component core in order for us to integrate with data so that we can bring it all together and provide a complete system for the imaging researchers. And that's where we decided to build both what is NeuroDesk and also CyGET into this platform. So effectively, the AIS platform is housed on a data management system called XNAT, and we integrate the NeuroDesk platform into that and provide neuroimaging resources to users. So basically, they can have the data uploaded into XNAT via an upload pipeline from the instruments. Data is already managed on XNAT, and then they can launch these interactive analysis desktops via NeuroDesk, and then they can do analysis on it. But now the thing is, we have gone past what is neuroimaging, so we have to step outside of what NeuroDesk is able to do. So we need to go to the next step in order to support this. So first thing is we want to extract what is the core framework of NeuroDesk into its own system, and that's what we're calling CyGET. Basically, it's the core of NeuroDesk, and we want to remove the neuroimaging software applications and things from it. And that's a CyGET sugar glider. There's a mascot. Yeah, I realize. And that's actually part of CyGET. We want to try and get a mascot for every single title platform if you can. Yeah. So basically now we take that core. Yeah. Now we take that core framework and we want to start building user-facing platforms and communities around the core framework. So for instance, we want to make NeuroDesk the neuroimaging focused community, but then we can also generate things like preclinical community and other communities as well that supports the different user bases that we're trying to aim for with the National Imaging Facility project as well. So on to what we want to try to move into with CyGET. So with CyGET, we want to take a lot of the stuff that's working in NeuroDesk and move it into the core framework so that then we can extend it out to our other users as well. And first thing is, in order for the container building process to start off, we need to have effective tools for the community to build these containers because they know the applications they want to use. We also, as we grow larger, we can't centrally start building too many applications as our user base grows. So we want to enable them to be able to build these applications as well. So we're putting a lot of effort into providing an interface that they can easily use to build these containers. So firstly, we've got a web form. So you don't have to use things like Docker files or Singularity files if you're familiar with those. The web form basically creates a Docker file or in the backend that can then build the actual container. And you get a very standardized template for it as well. So it standardizes things like metadata and licenses, which also feeds into potential discoverability features that we can build later on. Not only that, once they submit a recipe, we auto-build the entire container and distribute it via distribution system that we talked about earlier. And also, we run cloud servers of NeuroDesk itself, and it will be Cygate soon. So, and then we can have the user, after they submit a recipe, they build their container, have it loaded onto a cloud server, and be able to test the container and then submit it back so that everyone else will have access to it into our main repository. And we want to make sure that this end-to-end workflow of recipe generation and testing and submission is all just fully web-based. So they don't even have to download any of this onto their system and to do any of the testing. We'll provide the full developer tooling for them to be able to do this end-to-end pipeline. In terms of the user-facing side, we want to provide the virtual desktop. So basically a full Linux virtual desktop inside a container, so it's portable, because we need to support things like graphical user interfaces in a lot of visualization applications, but also it has a command line interface so that you can load the containers directly, because in places like HPC you need to be able to do that, or you can integrate it into your code base as well. And also on top of that, because we have containerized everything, we want to avoid dependency challenges. Lastly, the software itself, we make the full stack of software on the Cygate software repository available to all the desktops that we can. But the thing is, we actually don't download the softwares into their system, their client. It's streamed via a network-based file system called CVMFS, which is CERN's solution for large-scale data management and software management. What it effectively means is that we can make hundreds of software available, different versions of hundreds of software available, and users only pull down files that they're actually using. So they have availability to access any of it, but they only download what they need when they need it. All of this is also baked into Jupyter Lab, so we get the full power of computational notebooks. This means when a user wants to build their workflow, they can use Jupyter notebooks. That means they can bring code, documentation, and results together. The software is made available as modules, so they can mix and match their applications within the notebook, making it a very streamlined experience, especially to handle software versions. We also integrated AI agents and Copilot, so now you can build your workflow using an AI agent as well to help you get started off. And the notebook itself is shareable, citable, and publishable. And it enables things like teaching and learning platforms. So we want to enable two main collaborative models. One is a centralized collaboration, because as a portable system, we can put it onto a central server, which also has access to all the data, and multiple users from different nodes can come and use it collaboratively. Or if it's a case of something like data privacy or those kind of challenges, we can install the platform on different systems and have them run it decentralized as well. So bringing all of that together, so we can now also DOI the software container, so that makes it a citable object. We can link the data to it through various data sources. And then the platform's a portable system, so we're able to provide that accessibility and interoperability as well. And then you can, at the end of the day, take your entire workflow or your platform itself and DOI that and then submit it. So that's the target we're trying to do with this fair workflow. And I think I'll just skip a few slides, actually, so just to the end. Yeah, so, and this is how we're imagining the platform to go forward. We want to have Cygate be an underpinning core framework on which a lot of other different community-facing versions can sit. And then this is also supported by various data providers, and as well as research infrastructure supporting it underneath. And so I just want to thank all of these people who have helped with the platform, including my core team of 8 other members at UQ, the UQ RCC team, and the AIS team at UCIT as well. Thank you.